We're going to talk about negative exponents. Students find negative exponents tricky sometimes, but really what's happening is if you find a term that has a negative exponent, that means it's in the wrong part of the fraction. If you want to turn a negative exponent into a positive exponent, you need to take it to the other part of the fraction. So for instance, if you have a negative exponent in the numerator, that would be a positive exponent in the denominator. So let me show you what I mean. First, let's look at just x to the negative 3. Okay, well, you might be thinking that there is no fraction here for x to the negative 3, and that's true, but we can write this as x to the negative 3 divided by 1, right? Because when you divide something by 1, that doesn't change it. Okay, so we want to get rid of that negative 3, so since we have an x to the negative 3 in the top of the fraction, if we move it to the bottom of the fraction, it'll be an x to the positive 3. Okay, so in the bottom, we're going to keep the 1 we had before, and we're going to have times x to the positive 3. And then there's a question of what goes in the top. Okay, so if you're ever moving things around, you never want to leave a 0 behind. Okay, it's not going to make sense to leave a 0 behind. Instead, what you want to leave is a 1 behind. Okay, so what this ends up being is 1 over x cubed. Okay, so we'll do a few more of these and it'll start to be a little clearer what we're doing here. So let's look about 2 divided by y to the negative 5th. Okay, so this one's already in terms of a fraction. And so if we want to rewrite this with only positive exponents, we need to get that negative 5, that y to the negative 5th. And since it's in the bottom, we're going to move it to the top. Okay, so then this is going to be 2 times y to the positive 5. And again, what we leave behind is just a 1. Okay, so you're always going to leave behind a 1 when you're moving these things around. Okay, so but then this, of course, can be simplified because dividing by 1 is the same as dividing by nothing. So this is going to be 2 times y to the 5th. Okay, so let's look at this next example where we're going to mix some skills that we've learned before combined with negative exponents. Okay, so here we have x squared times y to the negative 4th, and all of that is being raised to the negative 2. Okay, so we dealt with how to deal with this exponent on the outside here when you have a sort of complicated base, and that is this exponent applies to everything in here. So this is going to be x squared to the negative 2 times y to the negative 4th to the negative 2. And then we've already talked about how you deal with a situation where you have a base that's raised to an exponent raised to another exponent. That means you just multiply the two exponents. So this is going to be x to the 2 times negative 2. Maybe I should just write parentheses. So 2 times negative 2, and then y to the negative 4 times negative 2, which will give us x to the 2 times negative 2 is negative 4, and y to the positive 8. And then if we want to write this with no negative exponents, we need to take care of that x to the negative 4th, and we do that by moving it into the bottom of a fraction. Okay, so this is going to be our final answer. Y to the 8th divided by x to the 4th. Okay. Now let's talk about the importance of parentheses. So this is something I mentioned earlier in a different video, but it bears repeating. So 3x to the negative 4th. This is not the same as 3x all to the negative 4th. Okay, these parentheses mean that everything in here is being raised to the negative 4th. So here when you don't have the parentheses, that means the 3 is not being raised to the negative 4th, only the x is being raised to the negative 4th. Okay, so if we want to get rid of that negative 4, we move that x to the negative 4 into the denominator and make it an x to the positive 4. Okay, right, because this is how you get rid of negatives. You move them either from the bottom to the top or the top to the bottom. As opposed to this. So here you have 3x being raised to the negative 4th. Okay, so if you distribute this negative 4 and apply it to the 3 and to the x, this is 3 to the negative 4th times x to the negative 4th. right? Because we've talked about how to handle these exponents before, right? It just applies to everything in here. And then if you want to get rid of these negatives, right, each of these is going to have to move to a denominator. So we're going to leave behind a 1. We always leave behind a 1. And this is going to be 1 divided by 3 to the 4th times x to the 4th. But then, of course, we can simplify 3 to the 4th. 3 to the 4th is 81. So you can check that if you don't believe me. But 1 divided by 81 times x to the 4th will be the answer here. Okay, so now we've done a few examples like this, and we're going to put together a lot of the skills that we've been learning about exponents and solve this problem. Okay, so it looks complicated, and it is a little tricky, but it's not too bad. Okay, so remember that parentheses comes first in your order of operations, right? Parentheses, exponents, then multiplication, division, then addition and subtraction. So to sort of make our lives easier, we want to simplify everything that we can that's on the inside of the parentheses before applying this exponent. Okay, so let's think about this. So we're trying to simplify what's on the inside of the parentheses. So let me write this out a little more spread out. So we've got 2, and then we've got an x, y squared, z to the negative 3, and all of that is 3 divided by 3 times x to the 4th times y times z squared. Okay, and all of that's being raised to the negative 2 power. Now, remember that you can't combine things that don't have the same base. Okay, so the x in the numerator has no bearing on the z's. Okay, those aren't going to interact at all. Similarly, the x's are not going to interact at all with the y's, and the constants aren't going to interact with the x's or the y's or the z's. Okay, so you just want to consider these things individually. So first, let's think about x divided by x to the 4th. Okay, so we're looking at the x's, and we have x over x to the 4th. So when we're dividing things that have the same base, what are you supposed to do with their exponents? Subtract them. So this will be x to the 1 minus 4, or x to the negative 3. Okay, similarly, if we look at y squared divided by y, we're going to subtract the exponents again here. And this will be y to the 2 minus 1, or just a single copy of y. And then if we look at z to the negative 3 divided by z squared, that will give us z to the negative 3 minus 2, or z to the negative 5. Okay, so what we have here is really, our original expression is 2/3 times x to the negative 3 times y times z to the negative 5th, and all of that is being raised to the negative 2nd power. So already things are looking a lot simpler. And now what we're going to do is apply this exponent on the outside to each of these terms on the inside. Okay, so this is one of our rules that we've talked about before. So we're going to take our number, our constant term, 2/3, and that's going to be to the negative 2. And then when we take x to the negative 3 and raise it to the negative 2, and then have y to the negative 2, and then z to the negative 5th to the negative 2. Okay, and we've talked about how to deal with these types of terms before as well. Okay, so here, this negative 2 applies to both of these. So this will be 2 to the negative 2 divided by 3 to the negative 2. And then this will be times x to the negative 3 times negative 2, right? Because remember, when you have an exponent raised to an exponent, you multiply those together. And this will be times y to the negative 2 times z to the negative 5 times negative 2. Okay, so if we want to turn, we would like our final answer to have no negative exponents in it. So first let's think about this. If you have a 2 to the negative 2, if you want to get rid of that negative 2, that's going to turn it into a 2 to the positive 2 in the denominator. And similarly, that 3 to the negative 2 in the denominator here is going to turn into a 3 to the positive 2 in the numerator. Okay, now considering our x's, we have negative 3 times negative 2, so that's x to the positive 6th. We have y to the negative 2nd, and then z to the negative 5 times negative 2 is positive 10. All right. So now we're just simplifying things still here. So 3 squared we know is 9, and 2 squared we know is 4. And then we have times x to the 6th. And instead of having y to the negative 2, we can write this as 1 over y squared, right? Because that's what happens if you want to get rid of the negative. You move it to the other side of the fraction. And then z to the 10th. Okay, so now we're ready to combine this all into a single term. So in the numerators, we have 9 times x to the 6th times z to the 10th. And then in the bottom, we have a 4 and a y squared. So this is the answer here. So if you remember, the original problem way up here was to simplify this expression, which is pretty complicated looking. And really what you do is you just consider each of these components by themselves, right? And you just take it one step at a time, and then you simplify, which gives you the final answer here. So this problem sort of puts together a lot of the skills that we've learned about exponents. So hopefully you found these videos helpful.